Welcome, everybody. It is Thursday, time to talk about weather, tropical weather. Today, our theme is hurricanes. It is April the 2nd, 2020. It is Autism Awareness Day, so hopefully you're wearing blue for Autism Awareness Day, and I'm so happy everyone is here. We've got a big group joining in right now. We start off with shout-outs like we start every Albert's Weather classroom. Shout-outs today to our friends watching not just yesterday, but over the last several days. And a shout-out to those that are on the live stream right now. Amelia is watching from Kyle. We've got friends from Round Rock watching. Sam's watching. We've got friends from Cedar Park watching. My buddy Michael, Dominic, and Anthony, they're back at it again for Tropical Thursday. They're ready to go. Keep sending me your photos. KVUE Albert, KVUE Albert on Twitter, on Facebook, on Instagram. You can even email me your photos, and we'll show some more for tomorrow. But hopefully everyone is having a great first half of your Thursday. And today we dedicate Thursday to the tropics. And when we talk about the tropics, we talk about tropical depressions, tropical storms, and hurricanes. So that's what we're going to focus in on today. Also, we'll talk about the difference between a hurricane and a typhoon and a cyclone. Is there a difference? We'll talk about that. We'll also have a case study towards the end when we focus in on Hurricane Harvey. You may remember Hurricane Harvey, especially if you lived here in the state of Texas. I know that a lot of you are watching from the Austin area, the Texas area. Harvey, big time, major hurricane impacting the Texas coast a few years ago. So we'll talk about that. We'll talk about the radar and satellite and technology that we use to track it as well. Mia, Michael, and Matthew all watching from Leander. Grace is watching from Potomac, Maryland. We've got someone from Maryland watching. Grace, welcome on in. So happy you're with us. Cooper from Kyle, Hannah, Nora, and Maya also here. Dominic is watching from Taylor, Texas. How's everything going on in Taylor? So let's get started into Tropical Thursday. And we'll start with this, the development of hurricanes, the development of tropical systems. So let's zoom in. We'll take a look at the system, and I'll be pausing this video just to kind of give you an idea. So in the summer months, whenever we start to warm up here across the United States, the oceans start to warm up as well. And during the summer months, especially mid to late summer, so late July into August into September, we start to keep an eye on the continent of Africa, especially here in Western Africa. So here's Africa over here. United States is over here. Texas is right in here. Here's Florida. And the reason why we're focused on Africa during the summer months, especially late in the summer, is we'll have a lot of thunderstorms developing here in Africa that move into the ocean. See all these clouds kind of right in here, not far from the equator? We call that the intertropical conversion zone. Throughout the year, these clouds are showers and storms, and we always have something going on here because it's in a tropical part of the world along the equator. So we'll watch for showers and storms to come off the coast of Africa. They'll move into the Atlantic, and by certainly August and September, waters in the Atlantic are pretty warm. So it all starts with just a normal shower, a normal storm in the ocean. Water temperatures have to be at least 80 degrees. The warmer, the better for development. And these showers thrive on what we call moisture. They thrive on that warm seawater, 80 degrees plus, almost like bath water. Sometimes, especially in the Gulf of Mexico, we'll have 90-degree water temperatures. So super warm water. So that allows for these systems to go from a normal shower or storm into a developing tropical system. And I'll show you the steps in just a second. Disturbance, to depression, to storm, to hurricane. But as we get into the ocean and these get stronger, they also start to spin. Now, these are just big blobs of moisture at this point. But as they start to spin, they get what we call more organized. And that organization allows these to be upgraded because they have more intense winds that are inside the system until they are strong enough that what we have an eye form. We call this an eye. And the reason for that is this system is spinning counterclockwise here in the Northern Hemisphere, here in the Atlantic Ocean, Gulf or Caribbean Sea. And that spin in the atmosphere is because of the rotation of the Earth. If you want to learn more about that, it's called the Coriolis effect, but we won't get too much into that right now. So as this system gets stronger and stronger, there you see the eye develop. This is a massive storm, and you'll have intense winds right along what we call the eye wall. So we'll talk more about how there is nothing really going on in here. all of the activity is pulling away from the center, and you have some intense winds and big waves that cause what we call storm surge right here along the eye wall. And that's kind of the most destructive part of the hurricane. Now, you can have destruction really anywhere from flooding to even tornadoes, but as far as wind and as far as the force of water coming in, it's going to be in this part, what we call the right front quadrant. So it was just kind of a quick lesson on that. We'll get more into all of it in just a second if you're a little lost. So let's kind of take you step by step, what we just kind of looked at in that animation. Again, it all starts with just a normal shower, a normal storm in the ocean. It's feeding off of warm seawater, 80 degrees plus, and then we categorize it as a tropical disturbance. It's just a massive clouds. This is a big blob of moisture out in the ocean. But whenever we start talking about a disturbance, we start as meteorologists start really looking at it and paying attention to it. And even in some cases, if this is close enough to the United States, the National Hurricane Center will even send aircrafts, what we call the hurricane hunters, to even investigate something weak like that, especially if the data, the models, the simulations, the computer technology indicates that this could blow up into something big in a short period of time. Now, as it gets stronger, then it gets categorized as a tropical depression. This is when there are sustained winds within this system of about 38 miles per hour, right? So not super, super strong. It's mainly just a rainstorm. But if it's out in the open waters and there's not a whole lot to kind of destroy it and not a lot to develop anymore, and it gets stronger and stronger, that's something really to start paying attention to as a tropical depression. Then as the winds get at or above 39 miles per hour, between 39 miles per hour and 73 miles per hour, and now it has that classic counterclockwise rotation, a big blob of moisture in the ocean or the Gulf, the Caribbean Sea, we then categorize it as a tropical storm. And at this point, producing big time rainfall can cause some big waves to move along coasts and what we call coastal erosion, kind of tear out the beaches at the sand a bit. But mainly with a tropical storm, flooding rains is going to be the big issue. Winds can still be pretty high, but flooding rains and even tornadoes will be possible in these tropical storms. And we saw back in the early 2000s to 2001, Tropical Storm Allison dump a tremendous amount of rainfall in southeast Texas and the Houston area. Now, once winds reach 74 miles per hour, the hurricane hunters are flying in there. Those are the folks with the Air Force that take this airplane, usually a C-130 aircraft, into it, and they drop these little packages, what it's called drop sounds. And these little packages are measuring pressure and wind and temperature, and all that data gets fed back to the National Hurricane Center. And once they find these winds within the system of 74 miles per hour or higher, it is then categorized as a hurricane. And we'll talk about the different categories of hurricane right now. So these categories of a hurricane go from 1 to 5. This scale is called the Saffir-Simpson scale. It's kind of an interesting scale in that it doesn't take into effect all the other life-threatening weather that you can get with a hurricane. So this scale, this category 1 to 5, is just focused on wind, right? As we just mentioned with the Tropical Storm Allison in 2001, people said, it's just a tropical storm. What's the big deal? Big time rainfall, lots of flooding with that system. So this only accounts for wind. It doesn't account for flooding rains, storm surge, which is seawater being displaced from the ocean and moving inland because of the force of the system, or even like tornadoes that you can get from tropical systems as well. So let's talk about the Saffir-Simpson scale. Category 1 hurricane is 74 miles per hour to 95 miles per hour. Then you get to 96 to 110 miles per hour. That's a Cat 2. Category 3, anytime the winds are of 111 miles per hour or higher, we then consider this a major hurricane. You can cause a lot of damage and have a lot of issues with a Cat 1 or Cat 2 hurricane, but then even more so with a Category 3 when you have intense winds like that. And again, this is just talking about winds. When you have winds like this in a big system, you also have a lot of ocean water being forced inland or towards the coast, what we call storm surge, and I'll show you an animation of that in just a second. Category 4 is when you have winds of 130 to 156 miles per hour. This is a big time hurricane. you're probably going to have numerous evacuations. So people that live along the coast are trying to get away from the coast, moving inland. If you're watching from the Austin area, a lot of people will come into the Austin area, stay in hotels and whatnot, just because the wind and the water is going to be so ferocious right along the coast and can do just a tremendous amount of damage. And then finally, there's Category 5. This is anytime you have sustained winds of 157 miles per hour or higher. Category 5 hurricanes cause catastrophic damage, can literally, as you saw there, wipe out homes either by the wind or by the sheer force of the water, the seawater moving inland. So that's a look at the Saffir-Simpson scale. So we talked just a moment ago about storm surge. So part of the hurricane is, of course, the wind and it's the rain. But if you have this big swirling mass of clouds, you're going to have a lot of force in the ocean that gets the ocean churned up, or the Gulf of the Caribbean, the body of water churned up. And all that water then gets forced inland. And that's what we call storm surge. And this can be quite dangerous and quite destructive. So you can see here, I'll pause this, how the storm surge will increase based on how strong the hurricane is. So think of it as a fan, right? So if you had a fan and you had a small swimming pool, if you had the fan on a low speed, you're going to have just a couple of ripples. But if you had this fan and it's cranked up all the way and it's blowing a ton of wind at the water is going to get pushed, right? You're going to have bigger waves. You're going to have it kind of go up against the other side of the pool. Other way to think about it is next time you're in a swimming pool and you start twirling around with your hands, right? You'll have these waves kind of splash against the side of the pool. And as you go faster and faster and you dig deeper into the water, those waves hit the side of the pool even harder. That's kind of a way to think about storm surge. And water is super powerful. We talked about in our introduction to meteorology class last week how water is super powerful. It only takes 6 inches for a normal car to become buoyant or float and be pushed off the road. So think about, we're talking about waves 20, 24 feet, coastal surge moving inland, and just taking homes out, taking roads out, taking bridges out. And I have an example of some of the damage that a storm surge event can do with a tropical system. So this is a photo from a few years ago, Bolivar Peninsula. This is near the Galveston area in southeast Texas. And you'll see this one home is the lone survivor. Just the construction of this home was built to withstand Category 4, Category 5 hurricane. But all this other stuff, these were where homes used to be, little beach houses. So here's kind of where the beautiful beach was. Here's a bridge that was taken out. So if you can imagine just a wall of water piling up along this peninsula, this little strip of land right along the coast, and just taking everything out with the exception of this home. So well-built homes that cost a lot of money to build can withstand this stuff, but it just costs so much money to build something like that. Okay, so let's talk about one other thing. So here's kind of the basic things that you can get with a tropical system. Strong winds, right? We talked about on that Saffir-Simpson scale, you can have a ton of wind with these hurricanes exceeding 100 miles per hour, heavy rainfall coming from the sky that can cause fresh water flash flooding. We'll talk about how Harvey was a big time issue with that a few years ago here in Texas. Storm surge, that's the salt water, that's the seawater being pushed along the coast. And then you can have tornadoes with tropical systems. So you can literally have almost every single weather phenomenon with the exception of like winter weather with hurricanes. You can get it all. Wind, flash flooding, freshwater flash flooding, seawater, storm surge, and also tornadoes. So let's kind of show you this animation on how that works out. So you have this spinning hurricane out in the ocean, in the Gulf and the Caribbean Sea, out in the open water, right? So it is encountering very little in the way of friction. It's just ocean water. As these systems get a little bit closer to land, these things, what we call the outer rain bands of the system, and then closer even to the heart of the center of the system, will interact with land. So you'll have this friction move over land, and that allows for these little quick spin up tornadoes. Typically, tropical tornadoes are small and short-lived and fairly weak. They're going to be probably EF0 to maybe EF2 range, right? I've seen these tropical tornadoes, these tornadoes develop within the rain bands of hurricanes, though, move at an incredible speed because they are wrapping around the hurricane. They can be moving. The forward motion of these tornadoes can be 90 miles per hour. We see that a lot. It's just Very, very hard to warn people, very hard to track them because they're moving so fast. And because they're so short-lived, like they'll spin up and then they'll spin back up. They'll spin down and then spin back up. The radar sometimes doesn't catch them either. So that's why during a hurricane making landfall, even a tropical storm making landfall, people are just sheltered in place, windows are boarded up, or they've evacuated, they've left the coast. But you don't necessarily even have to be along the coast to get tropical tornadoes. They can happen inland. For an example, here in the Austin area, next time we have a tropical system, a tropical storm or hurricane impact Texas, our two main concerns here in Central Texas will be flash flooding because of a lot of rainfall in a short period of time. And then also tornadoes, quick spin up tornadoes. Tanya's asking, are nor'eastern hurricanes the same and do they use the same scale? They do not. Nor'easterns are cold core lows. It's different. They have the same kind of spin. They're an area of low pressure, but they're different and they do not follow the same scale. Okay, so that's a look at the other threat that you can get with tornadoes. So let's talk about the difference between watches and warnings. We talked about during our severe weather lesson a week ago, and if you missed that on Thunder Thursday, last Thursday, the link provided, you can go back and watch it. But the difference between a watch and a warning, we talked about tornado warnings, severe thunderstorm warnings, flash flood warnings, and watches. A watch means that we're just on the lookout, that conditions outside may allow for some bad stuff to happen, whether it be flooding or severe weather or tornadoes, but we're just on the lookout and we have a plan in place. Warning means that it's either happening now or it's going to happen very soon, and you've got to put that plan into action. Same thing goes with tropical storm and hurricane watches and warnings. So tropical storm or hurricane watches are issued about 36 hours out when tropical storm or hurricane conditions are expected. You'll get them primarily along the coast, but notice how far inland they can go. So even in our area, I think during even Harvey, we had some tropical storm warnings in our eastern counties, kind of inland. So these can go inland. Primarily hurricane warnings, though, are going to be right along the coast. And tropical storm and hurricane warnings are when conditions are expected 24 hours or less. So that's kind of the difference between warnings and watches there. The only good news about hurricanes, as opposed to tornadoes, is tornadoes happen so fast. The warning time is minutes, and you got to get to the same place, but they only impact primarily a very small area, right? Either a neighborhood or a town. Hurricanes can impact multiple states, but because they're out spinning in the ocean or in the Gulf of the Caribbean Sea, we typically have several days to watch it and have people prepare. So that's the only good thing about hurricanes. Someone's asking, what's a nor'easter? Nor'easter is just a system. It's not a tropical system. It's a system that can produce a lot of similar conditions, but with winter weather, snow and ice and stuff. It pulls in some real cold air from the north. But hurricanes and nor'easters are not in the same category. Okay, so let's talk about this. This is going to be preparing for a tropical system. Back that up. This is mainly for folks along the coast. If you've ever lived in coastal areas, I lived in Corpus Christi for about 6 years. You're always, ready to put a plan into action, or you should be, how you're going to prepare your home, where you're going to go in case a big storm comes, and also kind of have a kit in place. This is also really good things to have handy, just in case we get a big severe weather event, even here in Central Texas, that knocks out power for a couple of days. It can happen, or we get into a situation, kind of that we're in right now. That's not weather related. So non-perishable foods, that's like canned foods that can last you 3 to 7 days. Plenty of water. A lot of people go out and buy a lot of bottled water. I don't think that's super necessary. You have tons of pots and pans and other containers in your house. You can fill them up. You can fill up the bathtub. You can have water that way. And then there's some other things. Anything that's battery operated, like radios, battery operated little TVs if you have them, cash on hand, stuff like that. This is mainly for those that live, though, right along the coast whenever they're preparing for a tropical system. So let's talk about the meteorology with this, and I'll come to my whiteboard right here. So this is all the different areas in the world where we can have tropical systems. And when I say tropical systems, we're talking about tropical depressions, tropical storms, and hurricanes. And in just a second, I'll show you, depending on where you are in the world, sometimes they're called something differently. I just saw a question about tsunamis. Tsunamis are caused by earthquakes. Tsunamis are not caused by hurricanes and tornadoes. So tsunamis is something completely different. So earthquakes cause tsunamis. Typhoons, though, we'll talk about that in a second. That's kind of another vocabulary word that we've got. So here's all the different areas in the world where you can have tropical development. The area that we watch the most is what we call the Atlantic Basin, Atlantic Ocean, the Caribbean Sea, the Gulf of Mexico, systems coming off the coast of Africa, moving into the warm waters of the Atlantic, the even warmer waters in the Caribbean and the Gulf, and then could impact the east coast of the United States or the Gulf of Mexico. We also keep an eye on, let me go to my whiteboard again. We also keep an eye on here. This is the Eastern Pacific Ocean. You'll have systems probably within the next few weeks developing here along coastal areas of Mexico and the west coast of Mexico. Some of these can even impact the Baja Peninsula of Mexico, the California Baja, this little peninsula there. And a few can even make their way as far west as Hawaii. So that's Hawaii on the map right there. So systems that are here in either the Eastern Pacific or the Atlantic Basin, and when we say the Atlantic Basin, we mean the Atlantic Ocean, the Caribbean Sea, the Gulf of Mexico, we call these hurricanes. So let me go to the next slide. We call these hurricanes. Now, anything that is off towards the west of the international date line and north of the equator, we call those typhoons. So typhoon and hurricanes are the exact same thing. They're exact same thing. It's just depending on where you live in the world, different parts of the world call them something different. So you'll see here, this is going to be the Western Pacific Ocean. So you got Southeast Asia. They call these typhoons over here. And their scale goes from typhoon to super typhoon. A super typhoon is the equivalent or the same thing as a major hurricane, category 3 or higher that we call here. Now, south of the equator, around Australia and out here in the Indian Ocean, they call these cyclones. Again, a hurricane, a typhoon, and a cyclone are all the exact same thing. It's just different parts of the world call them stuff that's different cultures and stuff like that. There are different names. We'll talk about naming in just a second, but the names here in the Atlantic Basin are different from the Eastern Pacific, or Eastern from the Western Pacific, different from the Indian Ocean, and out here towards south of the equator in the Pacific Ocean as well. But this is where you have most of the development across the world when it comes to tropical systems. And the reason why you don't have any down here is because of ocean currents. So ocean currents and weather currents are almost mirrored. So we'll put an area of high pressure out here in the Atlantic Ocean. We call this the Bermuda High. There's usually an area of high pressure out there. And we know from meteorology that high pressure spins clockwise, right? Just like a clock. So the reason why you have development in this part of the Atlantic Ocean is you've got warm waters from the equator being pulled up. Meanwhile, down here along the equator and south of the equator, you'll have cooler water being pulled in from the north. Same thing out here in the Eastern Pacific Ocean. Another big kind of a high here. You have clockwise flow like that. That pulls in cool water from the north. And that's why we don't talk about tropical systems in coastal Washington or Oregon. Sometimes you can maybe get a weak system to make its way into Southern California, but this is why you primarily have the tropical systems down here, because you'll have that cooler water pulling in from the north along the west coast of the United States. So if you've ever visited the Pacific Ocean, you'll notice that water is a lot colder than the Gulf of Mexico water or even here along the East Coast. So again, a hurricane and a typhoon and a cyclone, all the same thing, just different words for different parts of the world. There's that other vocabulary word that someone mentioned, typhoon. Typhoon is a big wave that's caused by an earthquake, and it's not in the same subject. So I know that can become kind of confusing because it's like typhoon, tsunami. I'm sorry, did I say typhoon? Tsunami is caused by an earthquake because of displaced water from the ocean and moving towards land. So see, I can even mess it up. There's so many words out there, but those two are so close to the same. So why are they different? They're not, Lucia, all the same. Again, just we call them differently here in North America versus down here around Australia versus Southeast Asia. Just like there's different words, like we call it a restroom in America and they call it the loo in like the UK. It's just stuff like that. Okay, let's talk about hurricane names. Once we get into hurricane season, which is now less than a month away, a month to go from yesterday, June 1st to November 30th. We call that hurricane season. That is typically, so good question, Jennifer. Typically, June 1st to November 30th is when we have most of the tropical systems. Now, we can have some that occur in May, if not even in April. That's happened before. And you can even have some that linger into December. But primarily, it's June 1st to November 30th when you have most of the tropical systems develop, and we call that hurricane season. And what are those months? June 1st to November 30th. What are majority of those months? Summer. So that's when we are the warmest here in the northern hemisphere, primarily in the Atlantic basin. You've got the sun that's north of the equator, warms up the ocean waters, and allows for tropical systems to develop. And that's the reason why we don't see a whole lot of tropical stuff in the winter months, because that's where the warm temperatures are down in the southern hemisphere. So here's a look at all the names. This coming year, the first one is Amanda. See if you can see your name anywhere here. Douglas. We've got Julio. We got Marie, Norbert, Polo, Simon. And you can see how they're in alphabetical order. And they'll go from girl's name to boy's name to girl's name to boy's name. And there's a list for 2021, 22, there you go. And those are the names that are going to be for the Atlantic basin, for the Atlantic Ocean, the Gulf of Mexico, and also the Caribbean Sea. So the reason why we have names is for forecasting and also for the public. It's just easier for us to give it a name, to talk about it. Whereas if we had, think of Harvey a few years ago that hit Texas. If we called that, tropical system number 10, people are like, what? But if you give it a name, it's just like, oh, Harvey. Oh yeah, we lived through Harvey. Or remember Andrew in 1992? It's just easier to communicate that message. Back in the 1950s, early 1950s, names were only girls' names, female names. And then in the 1970s, they went to a female to male name in alphabetical order. And what if you go beyond the list? That happened in 2005. That was actually my very first year as a meteorologist. After you get through the list, after you go to the Zeke, Zelda, Zeke, then you go into a different alphabet. It's the Greek alphabet, I believe, and it's only happened once. So we talked about hurricane season, June 1st to November 30th, right? The peak of hurricane season, when we typically have the most tropical activity, the most tropical storms and hurricanes, we could have 3 or 4 out in the Atlantic alone, is right in September 10th. This is when you have all the ingredients just right across the Atlantic basin for tropical systems. So September 10th is the historical peak of hurricane season. You'll see how you could have some stuff in May, and then a little bit in June, and a little bit in July, and then especially August into September, you have a super big increase in tropical activity, and then it goes down. Why do you think it goes down after September? What's happening? What time of the year is this? What season is this? Fall, right? So we start to cool down, and that allows the ocean waters to cool down, and then you see less tropical activity as you head into the fall months. And then by the end of November, you have little to no activity. So let's finish up the presentation by talking about Hurricane Harvey. Hurricane Harvey hit the middle Texas coast, Aransas County, the Rockport area. Unbelievable. 3 years ago, this coming summer. It was the strongest hurricane to hit Texas since 1961. Back in 1961, there was a hurricane named Carla. And Carla caused a lot of damage and destruction, but not as much as Harvey. Harvey, unfortunately, killed 68 people. More than half of those 68 were in the Harris County area of Texas. Harris County is where Houston's at, and primarily because of flooding. And we'll talk more about that in a second. One thing that surprised meteorologists a lot was just how fast Harvey got strong, how it went from a tropical depression, fairly weak system, to a major hurricane in just about 36 hours. So super, super fast development. The Gulf waters just off the Texas coast were in the upper 80s and low 90s, and it wasn't just super warm waters at the surface. It was deep. Like you could dive in and it would be super warm. And deep, warm water, 80 degrees plus, is a perfect environment for a hurricane to develop and for, like Harvey, to explode in intensity. So we'll take a look at the track for Harvey. And it all started on Wednesday, August 16th of 2017. It was a weak system out here in the Atlantic Ocean, and we had also been tracking this as just kind of a weak, what we call tropical wave, tropical disturbance, once again coming off the coast of Africa, but didn't really start to get our attention until it was out here in the Atlantic, getting closer to these little islands, what we call the Lesser Antilles. So like St. Lucia is right in there. You've got all these little islands here. Turned into a tropical storm before moving over the Lesser Antilles. That's when it got its name. Then was Tropical Storm Harvey. And then it got out here into the Caribbean Sea and encountered some rough conditions. There were winds above it that were kind of blowing the tops of the storms off, and that weakened the storm. And it basically was just kind of just a normal system at that point. It was just a disturbance when it was out here. And I remember when it was out here in the Caribbean Sea, we thought, oh, this is going to disintegrate. It's going to disappear, especially once it hits this part of Mexico, the Yucatan Peninsula. But that's not what happened. After it passed the Yucatan Peninsula, it encountered these seawater temperatures here in the Gulf of Mexico of, again, 88 to 90 degrees. And in 36 hours, it went from a tropical depression to a major hurricane as it got closer to the Texas coast, and then made landfall at 10 p.m. on Friday, August 25th as a Category 4 hurricane in Aransas County, the Rockport area. And then I'll show you some satellite images too. But then after it just caused this tremendous amount of destruction along the coast, wind and storm surge, it then sat over portions of South Central and East Texas and dumped just a historic amount of rainfall. So Harvey is one of those systems that I'll remember forever, because I was working this week when it was out here in the Caribbean Sea, and we all thought it was just done. It was going to hit the Yucatan and be finished, and then it just blew up into this historic weather event. So I'm going to show you a satellite picture here. Again, satellite picture is from a satellite that's orbiting Earth, taking a picture of Earth of where the clouds are. And this particular satellite is what we call infrared satellite. So these little brighter colors, whenever you see the whites like that, those are the higher cloud tops, the colder cloud tops, the most intense thunderstorms within the system. So this is August 24th. This is when it's in the Gulf of Mexico. It looks pretty decent at this point. And then you'll see how fast this develops into this monster hurricane in 36 hours. So this is August 25th, 1 p.m. So this is 9 hours away from making landfall. Texas coast is right in here. There you see Austin, and there you see the eye developing. That eye occurs because you have this intense counterclockwise rotation within the storm, and it pulls kind of the wind and the rain away from the center just a little bit. There's a physics force that is occurring that's allowing that to happen. It's called centrifugal force for those physics fans out there. So let's continue to kind of go. There it is making landfall on that Friday night, 11 p.m. And you see how you can kind of see part of the map. That's Aransas County right there. So within the eye, there's nothing going on. There's very little to no wind. You would be able to look up and see the stars, believe it or not. So you just went through this horrific storm with 100 plus mile per hour winds, gusts well above that, and then nothing. And sometimes in these eyes, you can actually have birds that are just flying in there trying to stay safe. And then minutes later, you'll be on the other side of the eye wall, and it goes from 0 to 60. Once again, it just gets ferocious once again. So back in the old days, before we had weather technology like this, people would actually say, oh, the storm's over. And they'd go out and start like picking up debris and stuff, and then, get hurt because the second part of the hurricane is coming in. So then it weakened as far as winds go, but then it just sat over what we call this part of the state, South Central Texas and East Texas, for days and dumped a tremendous amount of rainfall. So you'll see the kind of center of here on August 26th. This is that Saturday at lunchtime. It's a tropical storm at this point, and it's right here. But you can see a lot of the moisture, a lot of the rain is still out here in the Gulf of Mexico. And let me get my pin again. So what's happening is you then have all this rain coming right off the Gulf like a fire hose. And that fire hose of moisture, that fire hose of rain is focused all on Houston at this point. So this is when it started to get really bad for Houston as the rain just continued. And it was heavy rainfall, just terrible, terrible worst case scenario for the state. Let me clear my whiteboard. Hello. Really? Oh no. There we go. Sorry, computer froze. Stand by. Let me make this full screen again. So again, if you're just now joining us, see some other folks are just now jumping in. This is our lesson on Harvey. Did this? Oh, I locked it. That's why. Nope. Weird. Okay, we'll just get rid of it then. So let's go a little bit farther into the movie here. We'll kind of play the animation again, and this may be choppy on the live stream. But there you see it just continuing to spin, spin, spin. Here's August 27th at 5 a.m. You still have just a tremendous amount of rainfall focus over the Houston area. And now we're starting to get all that pipeline of moisture funneling right into the Beaumont, Port Arthur area. And now we have another flood emergency that's happening. So this is just awful, awful conditions that just was relentless. And then finally, look at this. It's August 29th. It made landfall on the 25th. It's 4 days later, and we still have moisture in the state. But after that, finally, it moved out of the state of Texas, and we started to calm down at least a little bit, but not before dropping just a tremendous amount of rainfall. This is a look at visible satellite. We showed you the infrared satellite. Again, that's showing us where the colder cloud tops are using an infrared filter on the satellite. This is visible satellite. Visible satellite uses the sun as the flash. So this is actually what this hurricane looked like from space. And notice how the picture is getting darker. That's because the sun is setting and it's about to make landfall. So here's Aransas County, Rockport's right there. And again, landfall was at 10 p.m. on that Friday. So notice how the sun is setting, and then we're not be able to see it as clear anymore. So we'll kind of start that from the beginning. That's the sun right on top of the hurricane. Corpus Christi is located right here. Austin would be up here. And there you see that stadium effect of that eye. And the most intense winds at this point are kind of right in here with this particular hurricane. So top wind speed of wind gust in Aransas County, where it made landfall of 150 miles per hour. Just a tremendous amount of wind. And all that wind, of course, is causing destruction, but it's piling up that seawater along the coast, what's called storm surge. Remember, we talked about that. This is look at the radar. This is showing us where the rain is, where it's most heavy. And this may be a little choppy as well, but you'll be able to see how this made landfall on the radar side and just dumped a tremendous amount of rainfall, especially from southeast Texas up in this area down into the middle Texas coast. And there it is, just kind of spinning, spinning, and spinning. This is another animation of satellite and radar. Kind of go through this a little slowly, so we'll pause it right there, making landfall. There's the hurricane on the radar, kind of overlaying on the satellite. So this is where you're having the storm surge, and you can see the little red right in there. That is where you're having the most intense winds, so that's likely where that wind gust of 150 miles per hour is taking place. And there's the rain just sitting and sitting and sitting for days, especially here along the upper Texas coast, the Houston, the Beaumont, Port Arthur area in that time frame. And then finally, it moved on off. So, Nederland, Texas, in the Port Arthur Beaumont area recorded the most rainfall from this event of 60 and a half inches. It still blows my mind that an area had 60 plus inches of rainfall, just incredible. This is a look at the area I forecast for in Central Texas. And I like to show this because this is just how wacky Harvey was. So our viewing area for KVUE goes out here to Mason County in the community of Mason. It goes out here to LaGrange and Fayette County. And there's Austin. And this is I-35 to San Antonio. And then Waco's up here. So just in our viewing area, and it's just 13 counties. It's not that big. Our rainfall from Harvey ranged from a trace in parts of Mason County, a trace, like it's not even enough to measure in a rain gauge, to nearly 40 inches in Fayette County. So it's just 40 inches in our eastern counties to just a trace of rain in our western counties. And then Travis County, where Austin is located, was kind of the split, depending on where you lived in Travis County. Western Travis County out around the lake had 4 inches of rainfall. Then you had like 8-9 inches of rainfall out here to the east of the interstate. So you just had that huge difference in rainfall. The heaviest rainfall for our area east of the interstate along the Colorado River basin. So this is why we had a lot of flooding along the Colorado River from Smithfield to LaGrange and then downstream. So that is freshwater flooding, and all the rainwater goes into these tributaries to the river, and then you'll get this. Oops, was that it? I guess so. you'll get all that rain that goes through the Colorado River. And Colorado River was just one of many rivers in the state of Texas that dealt with some big time issues. So I'll end on that. That was a introduction to. Oh, we went 42 minutes today. Look at us. Introduction to tropical meteorology. If you jumped on late, I see a lot more people are watching now than they were. If you jumped on late, this will be saved on the YouTube page, on the KVUE YouTube page, and here on my Facebook page if you want to look at the beginning of it. If you have any questions, everybody, feel free to type them on in. It looks like my comments stopped, so let me pull this up once again. So again, what you're looking at here is the satellite picture from Hurricane Harvey in August of 2017 hitting the Texas coast. And what I'm doing here on my phone is seeing if I can see some of your comments, because it looks like my phone froze just a bit. It's froze. It's lagging. Oh no. People are saying that. Okay, Dina. All right. So it doesn't look like we have a ton of comments and stuff, and it looks like my stream is lagging just a bit. So tomorrow is our final day for Albert's Weather Classroom. The promise was 2 weeks, and we got that 2 weeks for you. You can look at all the previous lessons on the link that is provided. Tomorrow is Forecast Friday, so definitely tune in at noon tomorrow. And Forecast Friday is focused on what's happening now. So it's just going to be me and you. I'll show you everything I look at. And tomorrow's kind of an interesting day because tomorrow afternoon and tomorrow night here in Central Texas, we actually have a slight risk for severe weather. We could get some big storms that can produce some heavy rain and maybe even some hail wind. So we'll have plenty to talk about. We'll analyze what's going on in the atmosphere. I'll show you what to look at. We'll look at all the forecast models and stuff. So it'll be kind of a cool briefing for all of us to do. Elsa's asking, what was the largest hurricane ever recorded? As far as size, aerial size, it was a typhoon. It started with a T out in the Pacific Ocean. It covered like almost the size of a western half of the United States. It was enormous. As far as the deadliest hurricane, that would have been the 1900 Galveston hurricane. Mary's asking about Katrina, the worst hurricane. So there's so many different categories on what was worse, loss of life, loss of property, size, and stuff like that. Katrina's definitely up there in the top list on a lot of different categories. Trish is asking about tornadoes. So Trish, I encourage you to watch the severe weather lesson that we did a week ago today. It's on the YouTube page or here on my page or in the link provided. And we get into all of that. We talk about how tornadoes form, how lightning forms. So watch the severe weather lesson from last Thursday. Melissa, that's a good question. Where did Harvey go after it left Austin? So it still was producing rainfall in East Texas, and then winds in the jet stream, upper level winds, carried it and moved it into parts of the Midwest and the Northeast, and then it was taken out to sea and kind of just fell apart after it left us. Oswald is talking about any hurricanes in Europe. Yeah, so during our hurricane season, you'll notice August, September, even in October, you'll get these systems that, again, come off the coast of Africa and then hook to the north and then to the northeast. And you can have some tropical systems, typically just tropical storms or depressions, impact the UK and stuff like that. Yeah, so they can get some systems as well. Paula is asking, can categories go over the scale? At this point, no, it's category 1 through 5 only. Right, Jillian, thank you. Amanda, what would you say be worse, a hurricane or a tornado? Well, it's kind of hard to say. Tornadoes are going to impact a much smaller location, right? The winds can be tremendously higher, but they're going to focus in on a neighborhood or a town and could travel multiple counties for the most part. Sometimes you can have, one that tracks right across the state, like a state of Alabama, something like that. We saw that happen in 2011. Hurricanes are just so much larger, can impact multiple states, right? So I think as far as loss of life and property, probably hurricanes. But I mean, if you have a large tornado hit a large populated area, you may have similar casualties like that. So yeah. How much rain did we get during Harvey? Sophia, over 60 inches in southeast Texas, over 60 inches. Our area, the Austin area, we picked up 4 to 8 inches, nearly 40 inches, 35 to nearly 40 inches in Fayette County around LaGrange. Lynn's asking what month is least likely to get hurricanes. June 1st to November 30th is hurricane season. Those are the months. That's the time frame most likely that you'll see tropical systems. Heather's asking the highest recorded storm surge. That's from Chase. Chase, I'm not sure about that. I have to do some research on that one. I'm not sure about that. Yeah, Sarah, I've seen the same thing. I literally saw that last week on my Instagram. Yeah. All right, everybody. We'll leave you with that for now. It is 12:48. We went almost 20 minutes longer than I wanted to, but hey, we got to spend some time together. I'll see you tomorrow for Forecast Friday. We'll talk severe weather chances for tomorrow. Have a good rest of the day, everybody.